Hello friends, in this session we will see some numericals or some old gate problems based on frequency domain analysis. Let us begin. Yes dear, this is 1991 question. What does it state? The system having the Bode magnitude plot shown in the figure below has the transfer function of what? This is the Bode plot given and we need to find the transfer function. First thing we will do is we will try to identify what are the corner frequencies. What are those? That is 0.05 and 0.1. What is the corner frequency? If you remember, corner frequency is what? It is the frequency at which the slope changes. See, initially here the slope was minus 20, then it changed here, it decreased, and then it again increased from here, right? That is the reason we say that at 0.05 and at 0.1, what has happened? Slopes has changed. That is the reason we have got 0.05 and 0.1 as the corner frequency. Is that correct? Yes. Now see here, before the first corner frequency, what happened? There is a slope of minus 20 dB per decade. Is that right? This means that there is a pole at origin. This means there is one pole at origin. How do you understand that? Because the slope is minus 20 dB and we know that one pole gives you minus 20 dB per decade slope. Is that right? Yes. So I can say that the transformation may look like this: K upon S. What is there next? We will see some. What is there? Right? Now, next thing is what? What has happened at 0.05? At 0.05, slope got decreased, even more decreased, right? At 0.05, see, this slope would have been minus 20 only, but because at 0.05, something happened that the slope got even more steeper, which means definitely at 0.05 we have got a pole, correct? Which means I should write that as s plus 0.05, correct? Yes. Now if you think of what is happening here, see what has happened at 0.1. The slope, the previous slope which was there, it would have gone here down like this, right? But at 0.1 somehow my slope has increased. This means that at 0.1 definitely there has to be a 0. Why? Because slope has increased, right? So I can say that at 0.1 I have got a 0, so it becomes s plus 0.1. Is that correct? Now let us see how to find the value of k. Okay, let me tell you how do we do that. If you remember, we used to show this particular thing in time constant form, correct? Time constant form. So what will I do is I will try to show this in our time constant form. How do I do that? Definitely this is k. If you think of time constant form in the sense 1 plus st form, which means what? This 0.1 has to become 1, which means let me take out 0.1. I'll take out 0.1. Inside, what is left now? Inside 1 plus s by 0.1 is left. Similarly, here also I will get s into this 0.05. I will take out, and inside what is left then? 1 plus s upon 0.05, correct? Now whatever is this one, whatever is this value, it is nothing but k new, right? This is nothing but k new. What is that? Right now if you see, it is nothing but k into 0.1 divided by 0.05, correct? This is the k new. Okay, now from the plot we can understand that this is 60, right? Which means, and at omega equal to what? 0.01 it has happened. And we have seen that at origin I have got only one pole, which means the value of k nu from the graph will be equal to how much? It is nothing but 20 into log to the base 10 k nu upon omega. Is that correct? And this is equal to what? This is not k nif. This one is equal to what, sir? This one is equal to 60 dB. We have seen that already. We have seen that is 20 log of k upon omega, or k upon s squared, k upon s, whatever is there, will be equal to the starting magnitude. This is the starting magnitude 60 dB. Now if you find from here, if you replace this omega should be replaced by how much? 20 log of k nif. Omega should be replaced by how much? Omega should be replaced by 0.01. So if you place here 0.01, what do you get now? This 60. Therefore you get the value of k nif to be equal to how much? If you solve this, you will get the value of k nif to be equal to 10. Now what will I do now? I want k but, right? Which means what is k? K will be, from this formula I get k nif into, if I send this one there, it becomes 0.05 upon 0.1. Is that correct? Is that correct? Right. So how much is k now? K will be equal to what? K nif is 10 into 0.05 upon 0.1 is equal to how much? 5 into 10 to the power minus 2 upon 1 into 10 to the power, or I can say 5 upon 100 divided by 1 upon 10. It becomes, this whole term is equal to 0.5. So 0.5 into 10 will give you 5. This is my k. Remember, k nu is for time constant form, and this k is for our general thing, right? Now if you just place here, what do you get? You get that if you just replace this k here, you will get this k to be equal to 5. So what do you get then? You get 5 into s plus 0.1 upon s into s plus 0.5. So it becomes 5 into s plus 0.1 upon s into s plus 0.5. So option D is the answer. But now wait, let me try to show that in time constant form and see what happens. See, do you agree that this whole thing is k nif? This whole thing is k nif. This is our time constant form, right? This whole thing is k nif. How much is that k nif now? We had that, right? It is equal to 10. So if I substitute this by 10, what happens is I get 10 into 1 plus s upon 0.1 divided by 1 plus s upon 0.05. What does this mean then? This means that it is equal to 10 into, if you see, 1 upon 0.1. 1 upon 0.1 is equal to how much? 10. So it becomes 1 plus 10s, right? Divided by what? Again, 1 upon 0.05 is equal to how much? It is equal to 20. So definitely this becomes s into, yes, definitely here was s, no? S was also there here, right? S into, yes, 1 plus 20s. Is that correct? So if you check out, we have one more option which is having the same thing, which is option B. It is 10 into 1 plus 10s upon s into 1 plus 20s, which means here both these options are correct. Both B and DS are correct, which means it is sort of like a MSQ question, multiple select question, right? Here we have got two options to be correct. Okay, now we will see some more problems. Yes, it is GATE 1996 problem. The closed loop transfer function of a system is given by, this is the closed loop transfer function of a system which is given. For the input r of t equal to sin t, the steady state value of c of t is equal to dash. That is what they are asking. Now if you check out, we can use frequency response here. Why? Because input is sin t. Input is not like, u of t, r of t, like that. Input is now sin t, right? So from sin t, what do we infer? From sin t, we infer that just by comparing it with sine of omega t, we understand that here omega is equal to 1. Correct? Omega is equal to 1. Now, let me tell you something. What is g of s? It is nothing but c of s upon r of s, which is equal to 1 upon 1 plus s. Is that correct? Yes. Now see, very important things. Very important, very easy thing. See, let us find magnitude. Before that, let me just show that in terms of g of j omega. What do I do then? I will just replace s by j omega. What happens then? I get 1 upon 1 plus j omega. So this is 1 upon 1 plus j omega, correct? Yes. Now let me find magnitude. What is magnitude here? Magnitude is nothing but mod of g, which is equal to 1 upon under root of 1 minus omega squared, correct? Correct. But we know that omega is nothing but equal to 1. So I can get this to be equal to 1 by under root of 2. Is that correct? Yes. Now what is our angle phi? Angle phi is nothing but angle of g, which is nothing but equal to, what is that angle? C. Definitely this is g of j omega. What will be the angle? Angle of numerator is 0. Forget about it. Angle of denominator will be what? Minus tan inverse of omega. Minus tan inverse. So imaginary part upon real part. Imaginary part is omega. Omega by 1. Right? Now at omega equal to 1, if you see, you get minus tan inverse of 1. Minus tan inverse of 1. Is that correct? Yes. Which is nothing but equal to minus 45 degrees, because we know that tan 45 degrees is equal to 1. Correct? So what is your answer then? Magnitude at an angle phi. So you get answer to be equal to 1 by root 2 into sine of t minus 45 degrees. 45 degrees is nothing but pi by 4. So if you check out, your answer is nothing but option D. Is that very simple? Yes. Now let us see one more problem. Yes, it is GATE 2001 question. What is it asking? The polar plot of a type 1 3 pole, type 1 3 pole, type 1 3 pole. Okay. Open loop transfer function is shown below. Okay, no problem. Then the closed loop system is what? Basically, they are asking you about stability, right? You just focus here. This is point at which minus 1.42 is there. What does this mean? It means that definitely minus 1 will be somewhere over here. Correct? Yes. Now, what I will do is I will try to complete this plot, and then we can check what happens. Okay. So this is the polar plot given, right? Now we will draw inverse polar plot of the same. So inverse polar plot will look like something like this. Correct? This becomes your inverse polar plot. And then definitely what will we do? After that we will do one semicircle will be there. Why? Because type 1. Type 1 indicates that you have got one pole at origin, which means definitely I will have one semicircle. So this will be one semicircle. This gets completed. Is that correct? So this will go like this, and this semicircle it gets completed. Now we need to check what are encirclements around minus 1. So this is minus 1. So if I want to check encirclement somewhat minus 1, let me draw a line over here like this. If you see, this line is cut 1 and twice in the which direction? Clockwise direction. This is clockwise direction, right? This is clockwise direction. This is also clockwise direction. So 2 times it has been cut in clockwise direction, which means n is equal to minus 2. N is equal to minus 2. Is that correct? What does this mean? What does this mean? This means that you have got two poles on the right half of S-plane. Is that correct? You have got two poles on the right half of S-plane. So answer is the system is unstable with two poles on the right half of S-plane. Why? Because encirclement is minus 2. Why? Because if you just see what is n, n is equal to OLP plus minus CLP plus. Is that correct? Open loop poles minus closed loop poles at RH. So open loop poles at RH. Are there any poles at RH? No, not given. No. Which means definitely when we say n is equal to minus 2, if I put this, if this one becomes 0, then it becomes n is equal to minus CLP plus, so it is nothing but minus 2. This means that there are two closed loop poles at RH. Is that correct? Yes, that is the reason answer is option D. Unstable with two poles on right half of S-plane. Getting my point? Yes. Let us see one more question. Yes, dear, it is GATE 2001 question. The asymptotic approximation of the log magnitude versus frequency plot of a minimum phase system with real poles and 1 0 is shown in the figure. Its transfer function is. Basically, we are supposed to find the transfer function. Magnitude plot is given. Okay. Now, first of all, let us identify the corner frequencies. What are the corner frequencies here? You get 2, 5 and 25. They are the corner frequencies, right? 2, 5 and 25. Let us see what happens. See, k upon. How do you get that? Yes, if you see what has happened before the first corner frequency, which is the first one, it is 2. Before the first corner frequency, is there any slope? Yes. What is that slope? That slope is minus 40 dB per decade. This indicates that there have been two poles at origin. There must be two poles at origin, because we know that one pole contributes to minus 20 dB per decade slope, which means two poles will give minus 40 dB per decade slope, correct? Yes. Now, next is what? Yes, which means two poles are taken care of. What is there? They have given that. Yes. Next one. Next one is what? What is happening at 2? What is happening at 2? The slope, which was initially minus 40 dB, has now turned out to be minus 60 dB, which means what? Slope has increased. If my slope has increased, which means what? Definitely at 2, there has to be a pole. So at 2, I have got a pole. So this becomes S plus 2. Is that correct? Yes. Now, at 5, what has happened at 5? Initially, the slope was minus 60 dB per decade, but at 5, what happened? The slope changed to minus 40 dB per decade, which means what has happened? Slope has increased. Slope has increased by 20 dB per decade, which means at 5, definitely there has to be a 0. So I've got S plus 5 over here because it's a 0. Now, let us see. What has happened at 25? At 25, what has happened? Initial slope was how much? Minus 40 dB per decade. But at 25, the slope got changed to minus 60 dB per decade, which means what? Slope has increased now, which means definitely I have got a pole at 25. Is that correct? This is what we have got. Now, next thing is what? Next thing is to plot, is to find k value, right? If you remember, we find k value by using time constant form, right? Let me convert this into time constant form. How does that look? Let me take 5 common from the numerator. I'll get s by 5 plus 1, or I can say 1 plus s by 5. 1 plus s by 5. Is that correct? Now, divided by. What do I get then? Yes. Let me take 2 common and 25 common. What happens is I get 2 into 25 common, inside which I get s squared into 1 plus, what do we say? S by 2 into 1 plus s by 25. Is that correct? Yes. Now if you check out, this is your k. This total is your k new. What is your k new? K new is nothing but k into 5 upon 2 into 25, which is nothing but 50. So this becomes 5, this becomes 10, so it becomes k by 10. So k new is nothing but k by 10. Is that correct? Now if you check out, what is k new? If you see, what is the starting magnitude? Starting magnitude is nothing but 54. So 54 dB is equal to 20 log of, what is there? K. What is k? K new. K new upon what? K new upon, what is there? 0.1. And we have seen that at origin we have got how many poles? We have got 2 poles. So definitely here I will get omega squared. So omega is what? 0.1. So I will get 0.1 squared. I will get here 0.1 squared. Is that correct? Now from this, if you solve this, you get the value of k new to be equal to 5. Correct? This is k new. But if you are interested to find k value, then k value will be what? See, k new is nothing but k by 10. So k is nothing but k new into 10. Right? So your k value becomes 5 into 10, which is nothing but 50. So if you want, you can directly replace this 5 to be k to be 50. So your transfer function becomes 50 into s plus 5 upon s squared into s plus 2 into s plus 25. Is that correct? This becomes your transfer function. Enjoy. This becomes your transfer function. Now, let us see one more problem. Yes, dear, it is GATE 2004 problem. Okay, see, let us check out the Nyquist plot of a loop transfer function g of s h of s of a closed loop system passes through the point minus 1 comma j0 in the gh plane. G of s h of s plane. The phase margin of the system is, what will be the phase margin? You please tell me. What will be the phase margin? See, since if you see, if it is passing through this point minus 1 point, this means that definitely the system is marginally stable. Definitely the system is marginally stable, which means PM is how much? 0 degrees. Phase margin is 0. We have seen that previously as well, right? So your phase margin becomes 0. So it is option A. Now, let us see one more problem. Yes, dear, it is GATE 2011 problem. The frequency response of a linear system g of j omega provided is in the tabular form. This is the frequency response, okay, which is given to us, correct? Now, the gain margin and the phase margin of the system are. That is what they are asking. What we will do first is, let us firstly write down the formula of gain margin and phase margin. What is that? What is phase margin? You please tell me. Phase margin is what? 180 degrees plus angle of GH at omega equal to omega GC, right? Now you please tell me what is omega GC? Omega GC is the frequency where the magnitude plot turns out to be 1. Is that correct? Which means if you check out here, this is 1. This is magnitude 1, right? Magnitude 1. Which means at here when my magnitude is 1, what is my angle? Angle is nothing but minus 150 degrees. So whatever angle I wanted here, angle of GH at omega equal to omega GC is nothing but minus 150 degrees. I've got it. So what is that equal to? 180 degrees plus minus 150 degrees. What is that equal to? That is equal to 30 degrees, which means PM is equal to 30. Correct? Half problem solved. Now, what is gain margin? You please tell me. What is gain margin formula? Gain margin formula is nothing but minus 20 log to the base 10 of GH mod of GH at omega equal to omega PC. What is omega PC first? Omega PC is what? It is the frequency at which the angle of GH is equal to minus 180 degrees, correct? So angle of GH is equal to minus of 180 degrees is here, and at that time what is the magnitude? Magnitude is 0.5. So definitely here if I put minus 20 log to the base 10 at 0.5 magnitude, what do you get then? What do you get then? The answer that you get is nothing but 6 dB. So the gain margin here is nothing but 6 dB. So answer is what? 6 dB and 30 degrees. So it is option A. It is option A. Now let us see one more problem. Yes, it is 2005 problem. The gain margin of a unity feedback control system with the open loop transfer function g of s h of s equal to s plus 1 upon s squared is. Gain margin they are asking, right? Very simple. How do you get that? What is gain margin? Let us write down the formula. Gain margin is what? Minus 20 log to the base 10 of mod of GH at omega equal to omega PC. Means the first thing we need to find is omega PC. What is omega PC? Whenever angle of GH is equal to minus 180 degrees, that particular frequency is called as omega equal to omega PC. Correct? Let us try to do so. So in order to do that, let us first write down M and phase. So you please tell me, what is g of s h of s? It is nothing but gs is how much? S plus 1 upon s squared, right? So what is g of j omega? Just replace s by j omega. You get j omega plus 1 upon j omega squared. Is that correct? What is that equal to? It becomes j omega plus 1 upon what? Minus omega squared. Is that correct? Is that correct? Yes. Now, if you think of what is the magnitude, now you please tell me. You please tell me what happens now. See, what is angle phi? What is angle phi here? Definitely, for the numerator you get tan inverse of imaginary part upon real part. What is imaginary part? Imaginary part is omega, omega upon 1, so it is tan inverse of omega. Is that correct? Now, here, what have you got? You have got this minus sign, which means here definitely angle is equal to what? Angle is equal to 180 degrees. If it goes on top, it becomes minus 180 degrees. That's it. Correct. Now, what is that? Omega PC is what? The angle of GH when angle of GH is equal to minus 180 degrees, right? So angle of GH is nothing but, so let me put this angle to be 180 degrees minus 180 degrees, which is equal to tan inverse of omega. What is omega here? Omega is, will now become omega PC. This becomes minus 180 degrees. So now minus 180 degrees minus 180 degrees will get cancelled. Is that correct? Yes. Now what do you get? Tan inverse of omega PC to be equal to 0. What is omega PC then? We know that tan inverse of 0 is 0. So omega PC becomes 0 radians per second. Is that correct? Yes. Now people start saying, sir, but how can it be equal to 0? It can be equal to 0, no? I will tell you. Wait. Just imagine. Now let us see what happens then. Omega PC is equal to 0. We have seen. Now let us find magnitude at omega equal to omega PC, because we know that gain margin is nothing but minus 20 log of 10 f of mod of GH at omega equal to omega PC. So what is mod of GH at omega equal to omega PC then? Let us find out that. For that, let me write down M phase, which is nothing but mod of GH. What is that? It will be nothing but what? For the numerator, what do you get? For the numerator you get under root of omega squared plus 1. Omega squared plus 1 divided by what? You get omega squared on down. Is that correct? Now, if I put omega equal to omega pc, which is equal to 0, if I put omega equal to 0, what do I get then? I will get under root of 0 plus 1 upon 0, which is nothing but what? 1 by 0, which is nothing but infinity. Is that correct? So, if magnitude is infinity, then definitely minus 20 log of infinity is also going to be infinity, which means gain margin is also infinity. This indicates gain margin is infinity. What does this signify? This signifies that whenever my gain margin is infinite, it signifies that whatever gain I increase in the system, how much gain I can increase in the system, whatever gain I increase, my system will never become unstable. Whenever my GM is infinite, whatever gain I increase in the system, my system will never become unstable. System will never become unstable, right? Yes. Now let us see some more problems. Yes, dear, it is GATE 2011 question. An open loop transfer function represented by the transfer function is given. Open loop system is represented by the transfer function is given. Now they are asking that if it is stable and of minimum phase type, it is stable or non-minimum phase type. Is it unstable? Is it unstable minimum phase type or unstable and non-minimum phase type? The first thing is, if you observe, the 0 is on the right half of S plane. It means that it is definitely non-minimum phase system. That is for sure. Non-minimum phase system. Why? Because whenever either your pole or your 0, if it is on the right half of S plane, then we say that it is a non-minimum phase system. So definitely it is non-minimum phase system. So definitely the A is not the answer because we have minimum phase, and definitely C is not the answer because we have got minimum phase. Now next thing is we need to check for the stability, because that is what is asked, right? So if you think of stability, how can you do that? I can tell you one small shortcut also. See, try to find gain margin. Gain margin. If gain margin turns out to be positive, then it is stable system. If it turns out to be negative, then it is definitely unstable system. Let us try to find that. So if you think of GM, what is GM? What is GM? Gain margin is nothing but minus 20 log of mod of GH at omega equal to omega PC, correct? Which means first thing is I need to find omega PC. What is omega PC here? Omega PC is what? Whenever my angle of GH is equal to 180 degrees, minus 180 degrees, then at that frequency is nothing but omega equal to omega PC, correct? So how do I find that? Let me first try to find the phase. How to find the phase? Before that, let me write down what is the transfer function. Transfer function is G of S, which is what? S minus 1 upon S plus 2 into S plus 3, correct? Now what is G of j omega? What is G of j omega? It is nothing but what? If I replace S by j omega, what do I get here? I get j omega minus 1 upon j omega plus 2 into j omega plus 3. Is that correct? Now if I try to find phase, how do I do that? Yes, phase phi is equal to how much? If you see numerator, if you see it, this one is in which quadrant? See, real part is negative. See, real part is negative, imaginary part is positive, which means definitely it is in the second quadrant. So it becomes 180 degrees minus tan inverse of omega. Is that correct? 180 degrees minus tan inverse of omega, because it is in second quadrant. So for the numerator I can write 180 degrees minus tan inverse of omega, minus tan inverse of imaginary part upon real part. Imaginary part is omega, real part is 1. Is that correct? Yes. Now what about next one? Is denominator will become what? Minus tan inverse of imaginary by real. Imaginary is what? Omega, so omega by 2. Then similarly for this one, what is the angle? It becomes again minus tan inverse of what is that? Omega upon 3. Imaginary part upon real part. Is that correct? Yes. Now we want that phase at what? Minus 180 degrees, because at minus 180 degrees only I can replace omega by omega PC. So let me write down here minus 180 degrees. So I will have minus 180 degrees, which is equal to 180 degrees minus tan inverse of omega PC minus tan inverse of omega pc by 2 minus tan inverse of omega pc by 3. Is that correct? Is that correct? Yes. Now, what do I get then if I put this 180 degrees there? What do I get then? I'll get minus 180 degrees minus 180 degrees, which becomes 360 degrees. Is that right? Or rather, minus 360 degrees, right? So I will get minus 360 degrees here, which is equal to what? Minus of, yes, definitely. All these terms are remaining. Now, if I combine all of them together, what do I get? What do I get? Let me first combine these two. Which two? See, let me write down this one alone. So it becomes minus tan inverse of omega pc. Let us say minus. Now, what will I do? I will try to combine these two. I will try to combine these two. What do I get then? What do I get then? I will get tan inverse of a into b if this is a, and if this is b, then I will get tan inverse of a plus b upon 1 minus a into b. Is that correct? Why? Because if you check out, what will I do? Let me just do this. Wait. Let me just write down whatever is left. Minus tan inverse of omega pc by 2 minus tan inverse of omega pc by 3. What has happened now? If I take minus n common, then this minus and this minus all are gone, correct? Which means it becomes 360 degrees is equal to tan inverse of omega pc plus tan inverse of omega pc by 2 plus tan inverse of omega pc by 3, correct? Is that correct? Yes. So let me just place this one tan inverse of omega pc here. What do I get then? Yes, plus if I combine these two, now what do I get? I know that because there is plus, then it becomes what? Tan inverse of a plus b upon 1 minus a into b. Is that correct? What is a plus b? This is half. Half plus 1 by 3 is nothing but what? 1 by 2 plus 1 by 3 is equal to what? 3 plus 2, which is nothing but 5 by 6. Is that correct? So definitely I will get tan inverse of 5 by 6 omega. 5 by 6 omega upon, what do I get? 1 minus, yes, definitely. Multiplication of these two will give you how much? 1 by 6 again. So this becomes 1 minus omega squared by 6, correct? So this is A and this turns out to be B. Then this particular formula which we use, right? Now, what do you get now here? What do you get here? You will get, you understand that it is 360 degrees, which is same as what? 0 degrees only, right? Which means what I can do is I can just put this omega. If I apply tan on both the sides, if I apply tan on both the sides, I will get tan of 360 degrees into tan of all of this. What do I get then? This tan and tan inverse will get cancelled. So you get omega pc plus 5 omega by 6 minus omega squared, correct? See dear, I will tell you how is that happening. See, I have got this 5 by 6 omega, okay. I will write 5 by 6 omega upon what? 1 minus omega squared into 6. 1 by omega squared upon 6, correct? Which is equal to how much? 0, right? Now, if you just omega pc, all are omega pc, all are omega pc, omega pc. Now, if you check out, what do you get? Omega pc plus 5 omega pc upon, what do you get then? Yes, definitely. If this is 1 minus omega pc, this is like this. This is 1 minus omega pc like this. This is separate, right? So this becomes cross multiply here. So you get 6 minus omega pc squared upon 6. So 6 gets cancelled and you get 6 minus omega pc squared, which is equal to 0, right? If you solve this particular equation, cubic equation is formed. What is that? 6 omega minus omega squared plus 5 omega equal to 0. If you solve this equation, you get omega pc to be equal to under root of 11. Under root of 11. Now, this is omega pc. I need to find magnitude at this omega pc. Now, what is the magnitude? Magnitude will be how much? Let us see. How do you see the magnitude now? Yes, magnitude is how much? Yes, it becomes, for the numerator it will be what? Under root of omega square plus 1. Under root of imaginary part square plus real part square. So it becomes under root of omega squared plus 1 divided by, what do you get then? Afterward, yes, you get definitely this one, under root of omega squared plus 4 into under root of omega squared plus 9. Is that correct? So I can put that into one shelter and I can write omega squared plus 4 into omega squared plus 9. Imaginary part square upon real part square. Simple school level things, right? Mathematics. Now, what do you get then? Yes, we have to place omega equal to how much? Omega equal to under root 11. If you just replace it over there, what do you get then? You get under root of, yes, under root of 11 squared is nothing but 11. 11 plus 1 upon under root of what? You get 11 plus 4 into what? 11 plus 9, correct? What do you get then? You get this equal to 0.2. Now, what is gain margin? Gain margin is what? Minus 20 log to the base 10 of GH mod of GH at omega equal to at omega PC. Now, this mod of GH at omega PC, we have got that to be equal to 0.2. So, this becomes minus 20 into log to the base 10 of 0.2. Correct? What is that equal to? That is equal to gain margin, which is equal to 13.97. Is it positive? Yes, it is positive, which means definitely system is going to be stable. So what do we get here? System is non-minimum phase system and system is stable at the same time. So where it is gone? Non-minimum and stable. Yes, it is option B. Definitely it is option B. Correct? Yes. Now let us solve some more problems. Yes, dear, it is GATE 2015 set 2. Okay, let us see the problem. Nyquist plots of the two functions g1 of s and g2 of s are shown in the figure. These are the Nyquist plots given. Okay, Nyquist plot of the product of g1 of s and g2 of s is what? You please check out this particular plot. We have already seen. What is this plot of? This plot is of a transfer function called as 1 upon s. We have seen this transfer function, right? Similarly, if you think of this one, this particular plot is of a transfer function called as 1 by s cube, right? See, 1 comes here, 1 by s comes here, 1 by s squared comes here, 1 by s cube comes up, right? That's way. So if you think of this is 1 by s and this is 1 by s cube, what happens now if you think of g of s is equal to g1 of s into g2 of s, g1 of s into g2 of s, right? That is what they are saying, product. So what is the product? 1 by s into 1 by s cube, which is nothing but equal to 1 by s to the power 4, and 1 by s to the power 4 will come in the real axis, because see, this is 1, this is 1 by s, this is 1 by s squared, this is 1 by s cube, and then this is again 1 by s to the power 4. So definitely this has to come over here on the real axis. So it is equal to how much? It is equal to option B. It will map as 1 over here. Is that correct? Yes. Now we will see some more problems. Yes, dear, it is GATE 2017 question. Consider the unity feedback control system shown. The value of k that results in a phase margin of the system to be 30 degrees is. Let us find that. First of all, what is your open loop transfer function? Open loop transfer function is GH, which is equal to k into e to the power minus s upon s. So what is that? GH equal to, which is open loop transfer function, it is k into e to the power minus s upon s. Correct? Now, let us try to find GH of j omega. Means let us replace s by j omega and see what happens. So you get GH of j omega to be equal to k into e to the power j omega upon j omega. Is that correct? Yes. Now, what is magnitude of GH of j omega? What is magnitude here? If you see from the numerator, now here I am supposed to tell you one important story. See, what actually happens is, we have studied this in complex numbers. Any complex number which is there, let us say z, it is represented in Cartesian form as x plus iy. It is represented as r at an angle theta in case of polar form, right? And then you have one more form there which is called as exponential form, and in exponential form we represent it to be mod of r into, or rather r into e to the power I theta, correct? Where whatever is there alongside e is nothing but the magnitude. Means, for example, if let us say if I have, let us say e to the power j omega only, then alongside e I have got 1, which means 1 is the magnitude, correct? And what about the phase? What about the phase? This theta is nothing but the phase. This theta is nothing but the phase. So now if you have omega, then this omega will become phase, correct? That is what is the story. Now, if you think of GH of j omega magnitude, what is magnitude here? Definitely, you will have k into 1 upon how much? J omega. J omega magnitude is what? Nothing but omega. So you get k by omega as the magnitude, correct? Yes. Now, we are supposed to find what we want. PM, right? We want PM, which means we need to have omega GC, correct? Because we know what is formula for PM. PM is what? PM is nothing but 180 degrees plus angle of GH at omega equal to omega GC, correct? Correct? Yes, means let us find omega GC now. What is that omega GC? Omega GC is the frequency at which magnitude is equal to 1. What is magnitude? Magnitude is k by omega equal to 1. That means you get omega GC to be equal to k. Correct? K by omega equal to 1. So this becomes omega, now becomes omega GC. Omega GC equal to 1, which means omega GC equal to k. Omega equal to omega GC. Got the point? So omega GC is equal to k. We have got that. Now let us find angle at that, because we know that PM is equal to what? 180 degrees plus angle of GH at omega equal to omega GC. Now let us try to find this angle of GH at omega equal to omega PC, omega GC, correct? Now what is that? Before that, let me try to find phase. What is phase phi now? For the numerator, it is going to be what? Since it is e to the power j omega, e to the power j omega indicates that omega is the phase. Omega is the phase, correct? So our omega is the phase, correct? I'm so sorry, it is e to the power minus s, correct? This is e to the power minus s. So this becomes e to the power minus j omega. Rest everything is okay, no problem. Now since it is minus j omega, so along with minus sign I have to consider the phase. So this becomes minus omega. So our phase becomes now minus omega for the numerator. Because see, you have got e to the power minus j omega, right? So if you compare it with e to the power j theta, what is there with j? With j you have got minus omega, which means minus omega is nothing but theta, which is nothing but phase, correct? Yes, so your phase from the, what do you say, numerator is equal to what? Minus omega. Now what is there for denominator? Denominator it is j, which means it is nothing but minus 90 degrees. So definitely j means it is plus 90 degrees in the denominator. When it comes on top in the numerator, it becomes minus 90 degrees. We have seen that, correct? Now if you just check, what is PM then? PM is nothing but equal to 180 degrees plus angle of GH at omega equal to omega GC, correct? Now what is omega GC? Omega GC is nothing but equal to k. We have seen that omega GC is nothing but equal to k. So if I replace it by k, what do I get then? What do I get then? Which means I will write 180 degrees plus this angle of GH is nothing but what? Minus omega minus 90 degrees at what? I will replace omega by k. What happens then? I get 180 degrees plus minus k minus 90 degrees. Is that correct? Yes. Now if you think this is PM, how much is PM given? PM is given to be 30 degrees. So let me equate that with 30 degrees. What do I get then? If I take this k on that side, I get k equal to 180 degrees minus 90 degrees minus 30 degrees, which means it is equal to how much? Therefore you get k to be equal to how much? K to be equal to 180 minus 90 is 90, 90 minus 30 is going to be 60 degrees. K is equal to 60 degrees. But since it is in degrees, we are not supposed to keep it in degrees. Why? Because it is gain. So in such a cases, what we do is very important. In such a cases, what we do is we make it in radians, correct? So in order to do that, what will I do now? I will just simply multiply by pi by 180 degrees to this 60 degrees. Then whatever answer I get, what do I get? I get 1.047. So your value of k is nothing but 1.047. This is the value of k. That's it. You just made it in radians. That's it. Converted it into radians. That's it. Now let us see some more problems. Yes dear, it is GATE 2008 question. Okay, let us see. The asymptotic Bode magnitude plot of a minimum phase transfer function is shown below. The transfer function has dash. That is the question. Options are 3 poles and 1 0, 2 poles and 1 0, 2 poles and 2 zeros, 1 pole and 2 zeros. Let us see that. See, first of all, please identify the corner frequencies. What are the corner frequencies? For example, see here. Here the slope has changed, right? So definitely 0.1 is a corner frequency. Then the same slope was there, minus 20 dB per decade. The same slope was there. And then here it got changed. So definitely, let us say here you have got some frequency. Let me assume that frequency to be, let us say, omega 1. Okay, no problem. Now if you check out what is happening, see what has happened. See, before the first corner frequency is 0.1, right? Before that first corner frequency slope was how much? Minus 40 dB per decade. It means that definitely there are two poles at origin, correct? Yes. Now after that, if you check out what has happened at 0.1, what happened at 0.1? Slope changed from minus 40 dB to minus 20 dB. Means slope got increased. Slope got increased. Slope got increased in the sense, what will happen now? What will happen now then? Yes, definitely at 0.1, I will be having some 0. So definitely this is k into s plus 0.1. There is some 0, correct? Now next, what happens at omega 1? What happens at omega 1? This minus 20 dB per decade got changed to 0 dB per decade. Means again slope got increased by plus 20 dB per decade. Which means what has happened? Again there must be some 0 at s plus omega 1. Is that correct? Yes. So if you just check out, you have got two poles and two zeros. Two poles and two zeros. So what is that? Option is option C. Transfer function has two poles and two zeros. That's it. It was so easy question. So we have solved all the interesting problems based on frequency domain analysis. Thank you.